All right, hello geometry. So today what we're going to be talking about is finding the angle measurement of an inscribed angle. So before we begin talking about the different theorems that we have today, we need to actually go through some vocabulary words. The first one is, what exactly is an inscribed angle? Well, an inscribed angle is an angle whose vertex is on the circle, just like this, and whose sides contain chords of the circle. So pretty self-explanatory. We have our vertex here sitting on one side, and then these chords go along the circle. All right, and we have something that's created from an inscribed angle, and that's called an intercepted arc. And this intercepted arc is actually an arc that lies in the interior of an inscribed angle and has endpoints on the angle, and it's highlighted here in red. So this is an intercepted arc. Okay, so it's an arc, which we know what arcs are, and it's being intercepted by this angle, basically. Okay, so if you understand those two vocabulary words, you're going to do great. All right, so the first theorem we have is theorem 11.9. It's called the inscribed angle theorem, if you want to get more specific, rather than just calling it theorem 11.9. And this theorem states that if an angle is inscribed in a circle, then the measure of the angle is half the measure of the intercepted arc. Okay, so basically that means is, given that we have circle P, so your circle P here, and we have this inscribed angle, BAD, okay? And we know that the measure from B to D is 46. We want to know what this angle is. We don't know what it is. Oh no. They give this really slick formula. Basically what that this theorem says, it says that whatever this measure is, we can cut it in half and we will find the angle measurement of that. So if we take 46 divided by 2 or multiply it by 1/2, however you want to look at that, you will then get 23. So my measurement of angle DAB or BAD would be 23 degrees. Really easy concept to understand, really easy theorem to grasp, okay? So from there we can go the opposite way. We can think about the corollaries to this inscribed angle theorem. And basically, this first part of the corollary states that if two inscribed angles of a circle are um, or congruent circles intersect congruent arcs or the same arc, then the angles are congruent. So basically what that's saying is that we have angle BAD here, and then we have BCD. And if you notice, it is creating the same intercepted arc here. And so what that means is if we know that BD is 80, then both these angles are 40. Okay, we also know that if both these angles are 40, because they share an intercepted arc of BD, we just multiply this 40 times 2 and we'll get 80. Okay, same thing here. We have this AB, we'll just call it E, there's no point there. And we have EDA because they share that, again, that intercepted arc, we can find the same sort of thing. It's easy enough. They're just stating a very basic fact, but giving it validity, which is very important. All right. So the final corollary to the inscribed angle that we are going to talk about is this one. It says, if an inscribed angle of a circle intercepts a semicircle, then the angle is um, a right angle. So basically what's that saying is if an inscribed angle of a circle intercepts a semicircle, so if you see this inscribed angle, it's creating a 90-degree angle, and it intercepts into a semicircle, so half a circle, then this has to be 90 degrees. okay? We also can go the opposite way. We can say opposite angles are supplementary. So if you see down here, you can kind of see a kite that's being created from my chords. This angle and this angle are 180, and this angle added together are equal 180, or are supplementary. Okay? So when you know these corollaries and that initial inscribed arc theorem, then you will, or inscribed angle theorem, excuse me, then you'll be able to solve any type of questions that may arise involving inscribed angles or intercepted arcs. All right, so please come to class with any questions. Otherwise, that's all I have for you today. Have a good evening.